Everybody here for our Waterloo Institute for Health Informatics Research Seminar. It's my delight to have Joel Dubin as our speaker today. We are having a Smarter Health Seminar on March the 28th, and the guest speaker will be Brian Haynes from the University of McMaster, or McMaster University. So please come to that. It's Wednesday, March 28th at 3 o'clock in Davis Center 1302. So without any further ado, I'll invite Maher Shanuda to introduce our speaker.
Good afternoon, everyone. It's my pleasure to introduce our guest speaker today, Joel Dubin. He's a professor in the Department of Statistics and Actuarial Science and the Department of Health Studies and Gerontology at the University of Waterloo. Dr. Dubin's research focuses upon development and utilization of longitudinal and survival analysis methods applied to problems in biomedicine and population health. He's working in a variety of application areas, including aging, smoking cessation, nephrology, and the study of adverse events in clinical trials. And today's seminar, he will talk about pharmacotherapy, smoking cessation trials, exploring the relationship between adverse events, compliance, dropout, and abstinence. Welcome, Joe.
Thank you, Heron, Shirley, and Dominic, and WIHR for inviting me to give a presentation today. So as Maher mentioned, you can see the title. We're going to talk about, I mentioned pharmacotherapy smoking cessation trials, but actually we'll be focusing on one particular trial that was conducted in Connecticut in the States. And we will be touching upon all those points mentioned, that is adverse events, compliance, dropout, and abstinence. Though we won't necessarily be considering them all simultaneously, we will be certainly looking at each and every one of those components and discussing them in the context of the particular trial. So I just want to provide acknowledgement of this work to Stephanie O'Malley and Ran Wu. Stephanie O'Malley and Ran Wu both are at Yale University at the Yale University TTURC, which Dominic had a question about, stands for Transdisciplinary Tobacco Use Research Center. And these are NIH-funded centers to look at items like smoking cessation, genetic predisposition to smoking or being able to quit smoking, a number of different factors in helping to get people to quit or why they're smoking or why they're unable to quit. And there's about 8 of these centers that are funded in the States. University of Waterloo actually collaborates with Roswell Park, which happens to be one of the centers here. I know Mary Thompson has some collaboration with them. Okay, so as an outline, this is a very brief outline. We have, and I'll be introducing the study to be focused upon today. Then I'll just go over one type of graphical method called the event chart and show how in this pharmacotherapy smoking cessation trial and in, I would say, clinical trials in general, especially with a bit of follow-up data and many different events that can occur, these event charts can be useful, and maybe you'll see applications in your own areas. Then I'll also talk about actually doing some data analysis with modeling, using some survival models for the particular data that we have, and then just a discussion and some mention of future work. Okay, so let me describe the motivating study. This was a randomized dose-ranging study of smoking cessation of the pharmacotherapy called naltrexone and with nicotine patch for participants motivated to quit smoking. So what happens is that I'll mention sort of the procedure, but basically every patient in the study received a nicotine patch on the day they quit smoking. And so the idea is that the naltrexone with the combination nicotine patch will help prevent patients from getting back, basically, quote-unquote failing or starting up smoking again after they quit. And the dose ranging aspect is that there will be 4 levels of doses, and so there'll be basically 4 treatment groups, and each participant will be randomized to one of those 4 treatment groups.
Sorry, Joel, is that
Yeah.
4 doses of naltrexone or 4 doses of nicotine?
No, nicotine patch is the same. So everyone gets the same exact nicotine patch on the quit day, and the day after they quit, they will be randomized and start treatment on one of 4 different doses of naltrexone. Good question. So there were some screening criteria. This is just some of that screening criteria, but participants need to be greater than or equal to 18 years old, not pregnant, reported to have smoked at least 1 pack per day over the past year. So they had to be a reasonable amount of smokers, not just, say, weekend smokers, for example. Had tried at least 1 quit attempt previously, so that was also an important exclusion criteria, and had a confirmed elevated expired carbon monoxide reading greater than 10 units here. So this CO will be an important feature of the survival modeling. We'll be using that as the actual response using the survival modeling. But basically, how failure was really categorized in the paper that was published last year on this trial is that basically there had to be self-report of smoking or not smoking, abstinence, and then confirmation with the CO reading. So if the CO reading was above a certain threshold, this 10 units, then the person was considered smoking. Okay, so there were 385 participants. Actually, there were 400 participants, but 15 never made it to getting randomized to the doses. So 385 participants made it to actually receiving treatment, and they're the ones that are going to be considered for the analysis in the study. So these participants received the day after the quit day, started 1 of 4 randomized doses of naltrexone, and these are the 4 doses that each participant was eligible to be randomized to: 0, 25, 50, and 100 milligrams. I'll just point out that 50 naltrexone, if you may have heard of it in other contexts, it is actually an approved treatment by the FDA for dealing with alcohol cessation. So, and what was found by actually Dr. O'Malley, who did some of the work helping to get naltrexone to that point of getting accepted for alcohol cessation, noticed that people were also not smoking as much as they were. Now, of course, for those of you who are familiar with it, smoking and alcohol use, they're very correlated behaviors. But nevertheless, there was thought that maybe naltrexone could also be used with a nicotine patch to help improve smoking cessation rates in addition to. So anyway, this is another indication that's trying to be where naltrexone has a possible use. And 50 was the approved medication for, or the approved level for alcohol cessation. And then these other doses are well. So 0 basically is the control group, right? Everyone receives nicotine patch, but 0 is where there's actually no naltrexone given, but everyone gets a dummy pill. Okay, and just point out, all received patch on quit day, and they stayed on medication for a period of 6 weeks. And that period is what we're going to be focusing upon, even though there's also interest in looking at longer-term outcomes, some of which were described in the 2006 paper. I'll list that reference at the end. But what we focused, the primary outcomes were all based on how the patients behaved during the treatment period. Okay, so failure for this analysis, and I'll mention this analysis is referring to the survival modeling that we'll look at after we look at some graphs, is based solely on the carbon monoxide readings during treatment period. So CO was greater than 10 units at any time point over the 6-week treatment period, participant was assumed to have failed the first week that occurred. Okay? So just to mention, if I didn't say this already, that CO is gathered on a weekly basis. And on a weekly basis also, there's daily recall information about someone's cigarette smoking behavior. So you come to an interview and you're asked, did you smoke over last week? How many cigarettes did you smoke each day? There's many other outcomes or information also queried about, say, drinking behavior, craving. There's all kinds of things that are asked at that interview. But in addition, then a CO reading is provided. But for this particular study, instead of using the self-report information, we're going to focus simply on the CO information. But a true analysis would be best to use both pieces of information, because the daily recall information is subject to bias, right? But even the CO information is subject to some bias as well, because it only has a half-life of, maybe one of you know even more than I on this, but I think it's about two or 3 days. So it doesn't really go back far enough to really evaluate if someone did any smoking over the previous week. We can look at a few days at a time. What's very important is dropout is also assumed to be a smoking relapse. I'll address this issue towards the end of the talk. But this is a very important assumption, and it's a general assumption for all these smoking cessation trials, and it might not be the right assumption. But anyway, it is an assumption, and that's what we'll use here. This results in what's referred to as discrete survival data or group survival data. This means that we have information at a discrete number of time points, and every subject, as long as they don't drop out, is observed at those time points. Those unique discrete number of time points that don't differ between participants. So what may happen in, for example, a true survival study where you might be looking at time to death, you might have day-by-day information on when someone may die. That's typically what happens. You can determine the day to death. And so there's not just, say, as in this study, there's 6 times that everybody could possibly fail at week 1, week 2, through week 6 during the treatment period. In fact, someone in a typical survival study could survive up until day 3, or day 5, or day 7, or day 9, 10, 13, etc. But this is called discrete or group survival data because the only information we have is that CO reading at that time point based on the analysis we'll be conducting. And so that's why it's called discrete data. And the analysis techniques we'll use are specific to that type of survival data. Okay. So aside from treatment group and these carbon monoxide readings over time, observations were also available for a number of other measures. Some were time independent, such as gender or sex, age, ethnicity, marital status, time independent within a 6-week period, that is. And then time dependent, which were, for example, adverse events that happened over the previous week. So that's also information that was gathered at each interview. Did you experience specific adverse events? And there's actually a list of possible events. These could be things from headache to nausea to there's things such as vivid dreams that actually the naltrexone may induce, and rash that might come from the patch. And so there's a number of, and itching. And so there's a number of different adverse events that might occur. Some might be specific to naltrexone, some might be specific to patch, some might be specific to withdrawal symptoms, right? So there's a lot of different things. We're not going to sort of divvy up how or divide how certain adverse events may be tapped into certain for certain reasons for the purposes of this talk, but it's a very important thing if someone's to do an honest evaluation of adverse events. You really want to know what's the plausible reason for those adverse events if you can tease that out. Other time-dependent information that was obtained each week, compliance, and weight. Weight is a very important consideration in smoking cessation studies, because what typically happens is that if someone stops smoking, they will put on weight. Smoking, it happens to be a good weight saver, and that's why a lot of people struggle quitting. And typically, women have struggle with quitting more than men, and one of the hypotheses is that it's because of weight gain. That's one of the main considerations. Although you'll find the gender quitting information in this study is different than what you'd expect from a typical smoking cessation study. I'll also point out, note that adverse events considered today will be of moderate and severe categories only. And this was because there was also a mild category, but this was very non-discriminating. Almost virtually everyone had mild adverse events. And the reason is there's a couple of different ways to query adverse events. One way is to say, did you have any adverse events this past week? Can you think of anything? So that's sort of an open-ended query. That will produce fewer yes responses than if you say, did you have a headache this week? Yes or no. And if you did, was it mild, moderate, or severe? Did you have nausea this past week? Yes or no. Was it mild, moderate, severe? And that will produce additional adverse events. And that sort of defined query is what was utilized for this particular study. And so we are not considering just the mild events where someone, oh yeah, I had a slight headache one day, and so that won't be considered. Moderate and severe are things that might have made you not be able to go to work one day. So something that actually had serious impact. Okay, so the goals today will be to look first at exploratory graphs of complex data. We'll start out with some simple graphs, and these graphs are under the type called event charts. And we'll see some different examples of event charts, and they sort of start simpler and then get a little more complex, but we could make them of far greater complexity if we wish to. And then we'll talk about some survival modeling. So any questions so far before we get to the...
questions at the end.
Okay. Yes. Thank you. Okay. So please hold your questions. Okay. So the first thing we're going to do, again, we're going to do some graphs, and then we'll get to some survival modeling. And what we're going to focus on for the graphs are only on those people who were early dropouts. And this is more for illustrative purposes, but also it's very informative in its own right. A full-blown examination of all the subjects in the study, all the 385 subjects, would be useful, but we won't show that here. But anyway, it would be important to consider all the subjects. But we're going to focus on the early dropouts. Remember, if anyone dropped out early, that is before the 6 weeks of treatment, they're considered a treatment failure. The week they dropped out, they're considered, that's when they smoked. Okay? So it is a component of smoking cessation, and these people failed to stay abstinent the entire time under the assumptions of the study analysis. Okay, so this is sort of a very scatter diagram, and these are 78 individuals. The participants are just ordered here, and the ordering was done just based on their ID that was in the study database. The ordering here is done with no other goal in mind at this point. We'll do some ordering that'll show some nice features of the data in just a moment. But I just want to point out that everyone here will have an X at the end because this is the final day of observation, and all these people dropped out early. So this is the time that we determined that they dropped out of the study. Okay, and this is in time and days, but this represents week 1, 2, 3, 4, 5, 6. And all these people dropped out, I believe, before day 38, and we consider them early dropout at that point. If there's a line, this means that they had more than just their final day, as in this person who just had their final day around week 4, and this person who had their final day after only coming one time, if they have a line, this means there was an adverse event observed. So this person up here had an adverse event observed in this. So this is the baseline week, and I should point out that this is when they received their treatment, and the quit day, and all that sort of happened right one day after the other. So the last time we might have seen some of these individuals was right when they received their treatment, and we never saw them again. And so anyway, so they're quitting at day, we say day 0. We could call it day 1. But anyway, this person, the first follow-up week ended up with an adverse event, and then ended up staying in the study until week 5. And I just should point out that at this point, we don't know what type of adverse event. We know that it was at least one moderate or severe adverse event. That's all the information we have in this particular plot. We'll look at a different plot that'll show a little more information, but we're not saying which type of moderate or severe adverse event it was. And if we wanted to really sort of drill down and figure out, why are these people dropping out early, and is it due to the adverse events, and is it due to mainly those that are induced by naltrexone or those that are induced by, say, withdrawal symptoms, we could dig deeper and find out a little more information on those items. Okay, so anyway, you can see some people have adverse events quite often, like this person, 4 different weeks reported adverse events. Whereas other people, again, maybe just had an adverse event once and then 2 weeks later ended up dropping out. Whereas others didn't have any adverse events reported, stayed in the study and just decided to quit. That could be for a number of reasons, right, that are not adverse event related. And so they might have not just been succeeding with the treatment, or they were, it's possible, maybe not so much in a smoking cessation study, but in a lot of studies people quit because they're doing very well. But in this particular study, it's most likely they, for one reason or another, they just either couldn't participate in the study for personal reasons or possibly because their treatment wasn't working well for them. Okay, so now we're going to take this data and sort it. And how we're going to sort it is based on their final day of observation. And this has far more information than the previous graph. You can see how many people quit at the baseline. And you can even see that there's some people, there's quite a few people, or anywhere where there's a dot, who actually had adverse event reported at the quit day, at their quit day interview, which is sort of strange, right? But basically, these are people, there could be some anxiety to go along with this quitting. Who knows, maybe they quit a couple of days prior and they're already experiencing some withdrawal symptoms. So it's unclear, but it should just be pointed out that even before they actually began treatment, or the same day, some people said, okay, I'm already experiencing some adverse events. We don't know how serious they are, but anyway, it's just to point out that there is a group of these individuals. So these are all the individuals who basically didn't make it past the baseline period. So there's about 17 of those individuals, which is about 20% of all the people who quit early or so. And then we had a number of people, and you can see quite a number of the people who quit at this period. Most of them ended up having some adverse events. Not all of them, but a lot of them had adverse events. So this is suggesting that maybe the reason they ended up quitting early was that there was some adverse event experience that along with maybe some other reasons, they decided that they didn't want to continue in the study. And then there's people who quit closer to week 2, week 3, week 4, and then there's a few people up here who made it all the way to week 5 but didn't quite make it to week 6. But you can see that's a smaller percentage than those that quit either right after baseline or week 1, right? So that's informative. So basically, if you made it past a certain point, then you're likely to, anyway, you maybe stayed in the study for a long period. Okay, yeah, because there are only 78 dropouts here, of which maybe 10 are at week 5, and there are about 300 people who actually made it through the study, a little over 300. So you can see that that's just a small percentage. If you made it to week 5, you were likely to stay in the study. Okay. The next is the exact same chart as the previous one, but what we've done here is we've included a size of the point where the event chart was observed that's in direct proportion to how many moderate or severe adverse events were reported at in that previous week. So we call this burden, and just by accumulating the number of these adverse events in a specific week, only in the past 7 days, anyway, that's one way of weighting sort of burden of these adverse events. But there are other possible weighting approaches that could be used. We could give greater weights to the ones that are severe versus moderate. There might be certain types of adverse events that are worse than others. Anyway, so just to point that out, but you can see that a lot of these individuals who quit after, a decent percentage of the ones who quit after just that first week, that first visit, they, at that interview, looking back at the previous week, they reported that they had some, pretty bad number of adverse events, and then they just never came back again in the study. There are a few other of these individuals who made it a little longer, but you can see the ones who reported these sort of big circles, they pretty much quit pretty closely after they reported this level of adverse events. So they just might not have been able to deal with withdrawing, with and/or with the naltrexone treatment, and possibly with a patch too. But those adverse events are more predictable typically. Okay. So the next one is another type of event chart, and this is another way of sorting the data. So we're basically taking the data we had in figure 2 here. We're taking this data, and then we're going to divide the data up by gender. Okay, it's just one way to divide the data, but there's other ways. And so on the top, we see all the male participants who dropped out early, and in the bottom, you can see female. Now, I mentioned about, it's interesting, so this is focusing specifically on dropout, and I mentioned that typically it's harder for females to quit, and some of it has to do with concerns of weight gain. Well, one nice thing about naltrexone is that it doesn't induce weight gain in the way that other smoking cessation methods incur. For example, bupropion is the one approved pharmacotherapy by the FDA for smoking cessation, and that actually some weight gain can be observed there. And then in other, say, behavioral approaches, or just cold turkey or whatever other approaches one considers, weight gain is a consideration, and often the females they report that that's one of the reasons they don't succeed in quitting. But here, just one component of failure is dropout. There are other components too. Someone might have continued all through the 6 weeks of the study, yet smoke during that time. They'd be a failure as well. But as far as dropouts are concerned, the males were about 52% of the sample, but they actually constituted the much higher percentage of dropouts. This is a significant result. And another thing that you can notice maybe is that with the females, there's about 50% or maybe a little over 50% of the dropouts from the females happen very early, okay, within the first 2 weeks. Whereas men, they sort of seem to have stayed in the study a little bit longer. Maybe they were able to deal with the adverse events for one way or another. I mean, this is just speculation at this point, but it is a pattern that you can see in these particular graphs. So these event charts allow you can break this up even further. You can look at male and female by age or by ethnicity, and then of course by treatment group, and that's the next one I'll show. I'll just end up showing by treatment group only, but there's many different ways that you can divide up these types of graphs. Okay, so the next one is by treatment group, and here maybe very understandably, there's a larger percentage of adverse, or I should say early dropouts in the highest dose. And so this may or may not be due to the adverse events that people are experiencing. You can see that there's a number of these early dropouts that have happened, and it could just be due to people not being able to tolerate the dosage. Now, I will report that there were a few participants, I should say, I don't know, maybe 30 or so, who actually were able to get their dosage reduced by half. So this is intention to treat. There are some of these people in the 100 milligram who might be here, say up here, who may have gotten their dosage dropped down by half to 50, but they still didn't remain in the study, and others who maybe did remain in the study. But it's just informative here to look at a good number of these 100 milligram folks left the study very early. And the 0 milligram didn't really persevere into the study as long, and it could be that they realized naltrexone wasn't working for them, and they just decided to drop out. Although there is a smaller percentage of those who dropped out in total compared to the other groups. So anyway, these are just some of the different patterns that one can look at when using these event charts. So this is all exploratory. It could be either to supplement work that you do with modeling, or it could be done to help generate hypotheses if you're basically running an exploratory kind of analysis. So that's what these graphs can help with doing. Okay, so now we're going to switch to looking at some modeling. And now, in the modeling, we're not going to focus just on the people who dropped out. They're going to be a component of what we're modeling, but we're going to focus on all 385 subjects in the study. So what we're going to do is we're going to consider the behavior of the hazard of weekly smoking based on the CO levels only over time. Okay. We'll consider time-independent predictors such as gender, ethnicity, marital status. But we will also consider time-dependent predictors, and including lag time-independent predictors. And this is a very important feature of this particular analysis. We want to see if what happened in the previous week is predictive of what's going to happen in the current week. So if you experienced adverse events, say, in the previous week, is that more predictive of you smoking in the upcoming, or in the current week? So, and compliance as well. If you didn't comply last week, is that more predictive of an upcoming failure? That is where failure is considered smoking, and smoking is based on the high CO levels, or not coming back, dropping out of the study. So those are the two ways to define smoking for this particular analysis. Okay, so what we're going to do is we're going to fit the data using discrete hazard models using a logit link. And this approach combines features of logistic regression and traditional survival modeling. Okay, so we're going to be able to report on the odds of someone, say of males failing, that is smoking, compared to females, which is sort of a similar interpretation we might make in a logistic regression. But we're focusing now on time to failure. Did they fail in week 1, yes or no? Did they fail in week 2, yes or no? Up to week 6 through the 6 weeks of treatment. Okay. So this is the appearance of hazard, and I'll just show this in tabular format as opposed to looking at a plot, but a plot would have been very informative as well. So here, what you can see is we start out with a risk set of 385. This is what we have in week 1. And the number of events we actually see at that first week's interview is 38 events. And again, this is some combination of actual reported people who actually reported a high CO level, as well as those individuals who never even made it to the week 1 interview. Okay, and I'll mention some that we may want to treat those individuals differently in a future analysis, but for now we're just lumping them in and saying they failed, they smoked. Okay, and the estimated hazard here is 0.0987. which is just a simple percentage. And then we can estimate the odds based on that estimated percentage. And you can see here, well, I have a comment about it. So this is a linearly decreasing hazard to start, basically linearly decreasing. It's not exactly linear. But then it's fairly constant from week 3 forward. That is, it doesn't really, well, it never dips below 0.05. Now, the best approach would have been to start it out linearly decreasing and then have a change point model and then have it constant after that point. But for simplicity purposes, for just the interpretation and analysis for this presentation, I left a linear time term in the fitted model. So it won't be the best fitting model, but it'll be okay. And I should just point out that we can improve upon how we do this model fitting based on what we see with the data here. Okay, so this is a fitted model on the time-independent variables only. So there's no consideration of information such as adverse events and compliance here, things that we saw over time. And we get a model that includes time, gender, marital status, and age, that all are time-independent variables that are considered significant. And I will interpret these coefficients and these the Z ratios just basically represent an approximate Z test. And if it's greater than 2 or minus 2, then you might think that the particular predictor had a significant effect. And the ones that weren't significant, like maybe or may not be surprising to you, but treatment group turned out not to be a significant predictor of failure for this intent to treat cohort. Where I will point out, just as an aside, in the paper from last year by the Stephanie O'Malley et al., it was discovered that we ended up doing a subset of just the treatment completers, people who actually made it to their week 6 interview, and it turned out that we did see some treatment effect. Okay, so anyway, it depends on the sort of the subset that you consider, but if you do the intent to treat, we did not see any significant effect of treatment. So this just mentioned treatment group is non-significant and not listed in the table above. The adjusted odds of smoking decreased by 14% each week. So this is just saying that, and that was sort of suggested in the earlier graphs by one type of evidence of smoking, which is dropout, right? And we saw that you're basically the longer you make it into the study, the longer you're likely to at least stay in the study. So that's in terms of dropout, but it turned out that sort of trajectory worked out for smoking in general. We also saw adjusted odds of smoking increase by 53% for males over females. So males are smoking more. They're not succeeding on this particular treatment as well as females, and this is an important finding, especially in consideration of what I mentioned, weight gain, and earlier studies that have shown that females don't necessarily do as well as males in quitting. And then also adjusted odds of smoking decreased by 47.5 for married versus unmarried. So there might be some sort of, and married means married or cohabitating. And it might just be that that there's, you're getting some sort of support from your spouse, partner, etc., and that enables one to decrease smoking. That's possible. And finally, adjusted odds of smoking decreased by 2.6% for every 1 year age increase. Well, I don't know how easy that is to interpret. I mean, this is based on just sort of this linear relationship between age and the hazard, but after doing a transformation. But I should just point out that the adjusted odd, people are smoking less as they're getting older. That was what was seen in that analysis. So there's some interesting findings, important findings about Maybe getting some support from a partner to help people not smoke as much. Maybe there needs to be more focus on males for this particular type of treatment, that it might not be working for males, and we'd have to figure out why, that kind of thing. So anyway, those are some of the highlights from the time-independent variable analysis. Now, what's more interesting is a fitted model on lag time-dependent variables, but this also included time-independent variables as well. And I'll describe what these things are, but this number.aes.lag is a lagged time-dependent covariate of adverse events that occurred in the previous week. And percent pills taken.lag is maybe self-explanatory, but that's compliance and based on the previous week. And then is that associated with current week's failure in that is in some evidence of smoking. So we'll interpret these, but you can see that there's if you had a large, this is positive, so having adverse events is positively associated with the future future smoking. And fewer pills taken is associated with smoking as well. So the people who happen to be comply more, that were actually taking their treatment, were actually doing better. And this could be, and we didn't see a treatment effect, but it just could be that people who are taking their pills more are just, maybe a little more motivated to quit is possible. So there could be other underlying reasons. People who are more familiar with this area might have a better explanation than I on that. And then we also see these evidence of gender and marriage is only both gender and marriage are only tenuously related, but there's still some associations there. So in any lagged analysis, one issue is that to be able to incorporate a lag, you have to chop off 1 week of the response data. Okay, so this is an issue. So basically, you have to see the number of AEs that were. If you're lagging the AEs, the adverse events behind the outcome, then you can only say, okay, the number of adverse events reported in week 1, does that predict the event occurring, the event being failure or smoking in week 2? And so your events start only in week 2, not in week 1 anymore. And so we're chopping off an entire week of information. And so we're losing power. Information. And so anyway, this is one downside of being able to incorporate what could be an informative predictors of these lags. And if you try to lag even further back, you're going to be losing additional weeks. So if you don't have that many weeks of data, using a lag can be dangerous. But it ended up being informative for this analysis. So the underlying hazards now assume constant over time. We could improve this, okay? We're just using a constant hazard. We're not even including time in the model here. We're just saying that it's always the same level. And age is no longer significant. So when I say could improve this, we could include something where maybe there's a linear decrease early on and then a constant rate after that. But we just kept it constant here the whole time. In every week, for every 1 count increase in the number of AEs in the previous week, there is about a 28% increase in the current week adjusted odds of smoking. So this is a result we get from this lagged analysis. So this is what might be considered an important finding. Again, when we say smoking, we don't know whether that was actually a high CO level or whether someone reported or whether someone didn't show up for their next interview, and that could be an important distinction, right? So anyway, that's just something to consider, and I'll mention this again in just a bit. And then, in terms of compliance, in every week, for a 1% increase in the number of pills taken in the previous week, there is what might be considered a small decrease in the current week adjusted odds of smoking, just 1.3%. But if we put it in sort of a higher order magnitude terms, That is, for a 20% increase in the number of pills taken in the previous week, there is over a 26% decrease in the current week adjusted odds of smoking. So that seems like a more reasonable scale to make that interpretation. And it was statistically significant, and it could very well be an important predictor of future success or lack of success in smoking, is compliance. And again, why it is, that's up to interpretation, and it could be that people who comply more are just more motivated and maybe better, maybe just more motivated to quit smoking, and it really has not as much to do with compliance as something else. And then the adjusted odds of smoking increased by about 62% for male versus females. And the adjusted odds of smoking decreased by about 55% for married versus unmarried. So these percentages go up, but the power went down, remember. So even though those percentages went up, it turns out that these aren't quite as statistically significant as they were in the time-independent variable analysis. Okay, so now I just want to mention what we've seen. So event charts can be an effective way to display complex data from smoking cessation trials. And I'll say for any longitudinal study where there's multiple events that could possibly happen. Here we just focused in these event charts. We did some sorting by other variables, but we just focused on, did someone have, yes or no, have at least one moderate or severe adverse event in any given week. And then in one, we showed the burden, so we actually summed up the number of those adverse events. And when did someone drop out? But we can include far more information than that. We could look at smoking, we could look at daily smoking information. If we had access to that information, we could look at alcohol use in the previous week. And we could look at compliance information in the previous week. So there's a number of different aspects of the information from just the smoking cessation trial that we could have included. And this is the case in any type of study where there's complex events to consider. Okay. And then it also turned out that discrete hazard models proved useful for this naltrexone study. And we were able to see not only just some interesting associations between certain demographic variables, such as marriage and gender, with success with smoking cessation, but we also saw some very important lagged associations, that is with adverse events and compliance on predicting success on this study. And so that's what's mentioned here. Okay, and then I'm going to go over this very quickly. We're running out of time. So it's just there's some future work, inclusion of additional time-dependent information in event charts. That's basically what I alluded to, where we can make even what we had seen have much more information. Of course, there's a trade-off, right? If you have too much information, then the plots can be a bit too busy, right? So you have to sort of be strategic in what you decide to plot and how much information you want to convey versus confusing the reader or the viewer. There's another point, a misclassification of response. This is sort of an interesting point, and these CO levels, where there is likely misclassification is if someone smoked, say, 6 days before, maybe during a weekend, and then they come in on a Thursday or Friday. They haven't smoked in the past few days. They say they didn't smoke, and their CO level suggests that, indeed, they didn't smoke. However, they might have really smoked. They might be lying. They might have smoked over the weekend, but the CO only goes back a few days. So there could have been some misclassification of response. And this is just something that people have to live with these smoking cessation studies, unless there's some more burdensome way of observing each individual and what exactly they're doing at all times. So, but that's an important component. Accounting for adverse events, including possible weighting. We did some simplistic ways of summing the adverse events over time, but we might want to weight them, again, possibly by distinguishing between the moderate and severe adverse events. Inclusion of additional predictors in the model. We didn't include baseline smoking. That could be important. There's a number of different things we didn't include in this analysis, but these could be very important. Prior quit attempts, craving, withdrawal, depression, weight, etc. So there's a whole bunch of things that we could add to what we've already seen. Some further refinement of models. As we said, the trajectory of the model over time. We could focus on this linear decrease up to a certain point of the hazard, and then a constant hazard after that. So that's something we would want to look at diagnostics. And yeah, the time variables, what I was just referring to, unobserved heterogeneity, etc. And then an important point that I've alluded to a couple of times is comparing results for failures due to dropout versus failures due to observed elevated CO. These might be different mechanisms on why people failed in the smoking cessation trial. And it's possible that we need to do separate analyses to determine what's associated with dropping out, if we can find that, and what's associated with failure due to elevated CO, and are these mechanisms different? And it's an important thing to consider. And so this was addressed in a paper by Borelli and Joe Hogan, who's a biostatistician at Brown. He was co-author on this in 2002. So that's recurrent events. Will people smoke not just once? We just looked at time to first evidence of smoking, but are they continuing to smoke? They might stay in the study and yet continue to smoke. There's multi-state modeling, looking at changing from one state, having an adverse event and not smoking, to changing to a state of not having an adverse event and smoking, or having an adverse event and not smoking versus, I should say, having an adverse event and not smoking to having an adverse event and smoking, this kind of thing. So there's different ways of modeling the data than we did with this discrete hazard model, and multi-state modeling is one possible way to go, and this needs to be investigated further. And effectiveness of treatment for compliers and completers, I alluded to that earlier as well. And just a few relevant references. This is the naltrexone study that I've been referring to. So this is just the application that from the overall evaluation of the effectiveness of treatment, and the effectiveness of treatment not on just on smoking cessation, but weight gain as well. So the analyses you've seen here weren't included in this particular paper. We're working on a follow-up paper to it. Event charts, you can find this particular reference on the American Statistician from several years back. And then, is it appropriate to assign smoking relapse for dropout the same way as for observed evidence smoking? This is that Borelli, Hogan, et al. Paper. It's in Psychology of Addictive Behaviors. Okay, that's it. Yeah, thanks.
So questions,
Thanks.
comments? See you here. Pass out a microphone to you. Just give people a second. Okay.
Thank you, Joel. That was really, really interesting. For those in the audience, we evaluate smoking cessation quit lines, and all of these issues come up, not related to the pharmacotherapy, but just related to the counseling as an intervention. I have a comment about the compliance issue and a question. Mm-hmm. It could be that people who were compliant with their pill taking are compliant with the directions to quit smoking. Mm-hmm. And so they're not necessarily more motivated to quit smoking, but they're complying with the intent of the trial.
Yeah, that's possible, yeah.
And I had a question. Was there correlation between adverse events and compliance? Did you look at that?
Not specifically, but it makes sense to, right? Because if you suffer an adverse event, maybe you'll stop taking your pills, right? And then eventually drop out of the study. So we saw that each of those were associated with, time to smoke, I should say. And so it could be that they're associated with one another as well. I'm not sure, though. We would have to look at it, but plausibly, yes, they would be. Yeah, but that's a good point.
And I guess when the 06 paper came out, there was a lot of discussion about that in smoking discussion groups, and one of the issues was whether or not you didn't have a pure control group. So you had the control group was getting the nicotine patch.
Yes. Yeah.
And do you have any information on compliance with wearing the patch and the dose of patch they were supposed to be using?
Yeah, what I can report on, because I spent a lot of time dealing with this, the analysis, the adverse events, and I can report that those in the placebo group actually had a higher percentage of adverse events specific to wearing a patch. That somehow the naltrexone, if you also took naltrexone with the patch, that those individuals, basically naltrexone, whatever adverse events occurred there, sort of swamped any consideration of the adverse events from the quote-unquote placebo group, that is, those just taking the patch. And this had, but the percentages weren't very high. It was less than 10%, maybe 8, 7%, who had itching and rash due to the patch. And then maybe it was only 1 or 2% of such reporting from those who actually were on naltrexone. And so anyway, that's just all the information I have. I don't know.
Do you know if people wore the patch at the required dose for the whole 6 weeks?
Yeah, I think their compliance with the patch was better than with the pills, but I don't know the numbers. Yeah, but obviously that is an important thing to consider. Certainly, yeah, that's a good point.
I have a bunch of questions if I could.
Yeah.
Just one dumb one is, when people smoke, to what percent is their oxyhemoglobin replaced by CO? I mean, what percentage are they're expiring 10 units, 10 parts per million, but what level is it?
I don't know. I don't know the answer to that question. I'm not. Yeah,
what I was thinking about is, and it's probably someone like Jake Teason may have an answer to this, is are there any other metabolic things that can be measured that would have a longer life than CO?
Yes. So there's some serum cotinine, I guess.
That means injecting. I'm thinking of touch only.
Oh, that I'm not sure. Yeah, I don't know about touch only, but I know through yeah.
It has to be collected, put in the refrigerator, frozen, and it has to be kept very cold to when it's collected and it's analyzed. And it's not really, like in a clinical trial, it's feasible, but in a population study, it's really not feasible.
What about I know that I have a very good sniffer, and I can actually detect anywhere near a person who's smoked in probably the last week, but particularly the hands, because it's exposed to I guess the aromatic hydrocarbons in the hand. So, I mean, are there any things like that? You might just might be something better than CO for longer term. A related question is: have you validated that a person who says I don't smoke? It doesn't, in fact. In drug trials, they found that if you ask a patient if they took their antihypertensive medication and they say yes, then they're honest, it turns out. Anything?
I just saw in, what was it, Nicotine and Tobacco Research Journal. There was just an article talking about trying to use some physiological information to supplement information from self-report. And it turns out some people do underreport how much they smoke. And some people actually overreport, believe it or not. But maybe they're not just estimating very well. But I believe they use cotinine to help sort of adjust how people report. And then they had some sort of complicated physiological equation that helped sort of hone in on what their actual smoking was and adjusted for things like weight and this kind of thing. And so I don't know. Yeah, so there's no gold standard as of yet. And if there is a gold standard, it's something that, as Sharon mentioned, might be a little too burdensome to deal with from both the cost and the issues with, getting blood, say, from an individual each week. Yeah, that's a good question.
The other one, you had looked at the adverse events in the relationship if you want the dropouts. What about adverse events in the group that continued through? What was the level of adverse events compared to that group as well?
Yeah, so we just looked at, in the paper, we actually looked at adverse events within each treatment group, and without considering whether they dropped out or not. whether they were successful or not. We just wanted to look at the overall adverse event status, and we focused only on the moderate and severe adverse events. I don't have percentages for you. I think I'm going to guess out of the moderate and severe, maybe, I can't remember. It's in the paper. It's been a while since I actually looked at that, but it's probably over 20% of individuals had at least one moderate or severe adverse event. It could be higher, it could be 30%. But I will say that between the treatment groups, there was no significant differences between any of the adverse events reported except for rash and itching. That is, the people who were in the actual control group who received patch only had a higher, statistically significant higher amount of reporting of those adverse events than people in the other groups. But it is known that things like naltrexone will cause nausea, and it was shown that there was a trend that there were higher amounts in the higher dosage group, highest dosage group, the 100 milligram group, than in the placebo group, but it just didn't turn out to be statistically significant.
Now, the other thing was, did you gather evidence as to whether the people in the study also drank so that the naltrexone might have other effects on the
no, that's an excellent question. There is some information. We haven't, there is some information, I believe, that was reported in this 2006 paper about drinking. I wasn't part of that particular analysis. I can't remember what was reported in the paper, but there is going to be another follow-up paper where they're focusing specifically on alcohol use and how that's related to success with the treatment. And it's an important outcome because of how correlated those behaviors are.
And the other one was if their I want to say spouse here, if their partner seems to be a factor that they have a partner, then did the partner smoke or not? Did you get information?
Oh, that's a great question, and certainly, well, we saw that people who were cohabitating or married did better than those who weren't. However, it would be great to break that down to see is the person you're cohabitating with smoking or not, right? And it could be that the person was pushed into the study, maybe because they realized their partner is not smoking and it was too burdensome to the household or whatever, and so they went into this, and maybe they were more motivated from that vantage point, as well as getting the support from their partner during that time. But if their partner was smoking, no, it's an excellent question, and there is a positive, there is a correlation between other people smoking in the house and having trouble quitting. So it's a good question. Yeah.
Charlie?
Just going on from that, I've had friends that have tried to, both husband and wife have tried to stop at the same time.
Yeah.
And the female got very discouraged because it seemed so easy for her spouse to quit versus herself.
Yeah.
And I understand that could be just because of it's more addictive for females.
Yeah.
I don't know if that's true or not, but that's what I've heard. Is there anything on that? Like you talked about that it seemed to be supportive, but in this case it became a deterrent for her to continue on when it seemed so hard compared to.
Well, there was only one person per household in this study, so to make sure that the participants were independent in the study. So if two people wanted to quit, only one of the spouse could try. And it was seen that having a partner was helpful. So it could be that the partner was smoking in the past and had already quit, and then that helped induce or at least is associated somehow with the second person quitting. But it's unclear. But and it also is interesting that men, that women did better than men.
I found that interesting.
So that's an interesting finding as well, in this particular study.
I guess my only other point is we had a really excellent presentation about 4 or 5 months ago from Ben Schneiderman with regard to visualization software. And I cannot remember which things, but your event approach is a visualization technique. And he gave us examples we've looked up since then at Spotfire. I don't know if you've ever had a chance to look at that. It's www.spotfire.com, I believe. And it's about $1,000 a year, but it's an incredible visualization package. And another person in the institute is interested. Two others that are interested in visualization. Kathy sorry, I can't think of it. Kathy Burns in system design engineering is written on this, and Wayne Oldford is also, you know him very well, and we're working with him related to a major study, clinical neurology. So it might be some people that kind of would like to look at this data as a visualization opportunity. It might reveal other things beyond event charts.
No, that's a good point. Yeah.
Any other final comments or questions? Thank you very much.
Thank you.